Suddenly love so Suddenly love so Suddenly lost so everything to you. Will shine again to you. Suddenly lost so suddenly lost so everything to you. Will shine again to you. Suddenly lost so suddenly lost so everything to you. Will shine again to you. Suddenly lost so
Sir Arpan, sir. How are you
Hello,
today?
I'm fine. How are you?
Good. Thank you for coming.
Not at all. It's really my pleasure to join in today.
Yes.
Yeah, thank you. Thank you for joining.
Hello, Professor Pujwan.
Morning, Professor. Thank you for joining.
I'm trying to set up my systems a little bit.
Yeah, we will start in few minutes. I think people are still coming in.
Okay. Is my screen visible now?
Yes.
Yeah.
Okay.
Okay.
Thank you so much. So I made little bit of changes to the presentation, you know, by adding these images which you had shared with me.
Right. No problem.
That has
You,
been very
you
helpful.
will share it by yourself, right?
Yeah, I'll share it from
Yeah.
my side
Okay.
only.
No problem.
Can you share with us later on, probably for after the presentation?
Yes, I can do that. I've already shared the presentation with you. Only difference is I've added this, the top, the motif, the background.
Okay. All right. Okay.
Only difference. The
Yeah.
content is same.
Uh-huh. Okay. I think the MC is about to start. Right. Okay. Silakan, Mbak.
Ladies and gentlemen, now we will begin the second session of our conference today. And the keynote speaker for this session is Professor Arpan Kumar from Monash University, Indian Institute of Technology. And this session will be moderated by Dr. Tatang Taufik Ahmad. So for our moderator, Dr. Tatang Taufik Ahmad, the time is yours.
Thank you.
May I start?
Yes, Honorable Department Head of Technology Management, Professor Dr. Yunyoman Pujawan, leaders of the academic community of Institute Technology 10 November, distinguished keynote speaker, Associate Professor Dr. Arpan Kumar, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. My name is Tatang Ahmad Taufik. I'm from the Department of Technology Management Institute Technology 10 November. It gives me great pleasure to extend to you all very welcome and to say how grateful we are to you, distinguished guests, keynote speaker, presenters, and participants who have accepted our invitation to convene this sixth international seminar on Science and Technology 2020. I would like to take this opportunity to welcome the participants who are from various different institutions or affiliations and places. This morning we have Professor Dr. Daniel Prayogo, which is in Australia, and this afternoon we have Associate Professor Dr. Arpan Kumar, which is in India, and some of you may be in Cambodia, Great Surabaya, Great Malang, Great Jakarta, and me myself, I'm in Tangerang Selatan, Banten. So basically we are all in different parts of the world. As mentioned this morning, the 6th International Seminar on Science and Technology 2020, with the main theme of fostering innovation projects for business growth, hosted by Graduate Program of Institute Technology 10 November in a cooperation with the Department of Technology Management. It is gratifying to note that the agenda of the seminar covers a wide range of very interesting items relating to hard engineering and soft engineering of policies and management as well, and especially those directly related to some very important aspects and in the spirit of fostering innovation in many forms. By the way, as probably you already knew, we are pleased to inform you that most of the presenters in the seminar this time are millennial generation. Ladies and gentlemen, we still have a great variety of talks ahead of us, but to deepen and enrich those topics, we have a very important keynote speech by Associate Professor Dr. Arpan Kumar. So allow me to briefly introduce the keynote speaker. Dr. Carr is an associate professor in the Information Systems area at GMS, Indian Institute of Technology, Delhi, India. in the area of Information Systems, Department of Management Studies. His research interests are in the domain of data science and artificial intelligence or machine learning applications, digital transformation, internet ecosystems, social media, blockchain, and ICT-based public policy. He has authored over 100 peer-reviewed research articles and edited 6 research monographs, including bestseller. His studies have been cited few thousand times. He has served in advisory role to Ministry of Electronics and IT, Department of Science and Technology, and Telecom Regulatory Authority of India for critical national projects. He has been associate or coordinating editor, as well as editorial board member of reputed journals like International Journal of Information Management, Advances in Theory and Practice of Emerging Markets, International Journal of Electronic Government Research, Journal of Operations and Strategic Planning, Information Systems Frontiers, and Global Journal of Flexible Systems Management. Previously, he has worked at IIM Rohtak, IBM Research, and Cognizant Consulting. He has also generated over 18 crores rupees through research grants, advocacy, and training projects from national and international governments and multinational enterprises. Over the years, he has received numerous awards and recognitions for his research from several organizations, including the Association of Indian Management Schools, International Federation of Information Processing, Elsevier, Tata Consultancy Services, IV Cases, Project Management Institute, IIT Delhi, BK Birla or BIMTech, NTRO, and IIM Rohtak. Today, Dr. Arpan will be speaking on theory building in data science research. Ladies and gentlemen, Associate Professor Dr. Arpan Kumar.
Thanks a lot, Professor Tatang Ahmed Taufik. Thanks a lot for inviting me today here, Dr. Dinarayanan, Professor Newman Pujwan. It is really a great pleasure for me to deliver the keynote in the 6th ISST 2020 International Seminar on Science and Technology. So when I received this invitation, the first thing that occurred to me is, how can I contribute something? How can I talk about something which would have a very high impact in terms of people who are working in the area of how technology, innovation, and business growth can be impacted. So I thought that maybe a recent publication of mine, which consists of theory building and big data driven research, moving away from the what towards the why, it would be an appropriate topic for discussion in this. So without further ado, this is basically an opinion paper written by myself and Professor Yogesh Dwivedi from Swansea University that I am going to present and talk about in this keynote. So I'll give a brief background of the research agenda or what drives this entire domain. In recent times, what we have seen is a lot of services, a lot of digital transformation has happened. For example, you want to order something, you order something in e-commerce. You want to shop for groceries, sometimes you shop for groceries using e-commerce platforms. You use social media very actively from different platforms, sometimes from your mobile phone, sometimes from your laptop. Your mobile phone is connected as a device to multiple other systems and services. All this is creating a huge explosion of what we call as big data. This big data is characteristic, by velocity, high velocity. It is being created with a high, speed, high volume. You're typically seeing within a couple of minutes, couple of hours, the data that is getting created in the system is in GB and TB, terabytes. It has a lot of variety that is typically, that this data that is captured is consisting of images, unstructured text, and then it has a lot of noise also. But if you can analyze this data in terms of velocity, volume, variety, and veracity, what it typically does is it adds a lot of value to the organization. And this is basically kind of stimulating big data driven research in recent times. But what is happening in these huge amount of focus, which has been driven by big data driven research, these days, every editor is getting probably out of every submission in an IS journal, at least 20 to 40% of the papers are big data driven or data science driven submissions. What's happening in this submission? There is a lack of theory building, which contributes back to information systems. I'll talk more about this. Due to which, what is happening many of the times, the journal editors, a lot of times people like us who are doing a lot of reviewing or who are doing a lot of associate editor kind of responsibilities in journals, a lot of times we don't find sufficient theory building in information systems, which creates a problem for us to take this forward in publishing in a information systems journal. The challenges is whenever you're doing a data science driven research and it does not contribute to theory building in information systems, there is a lack of generalizability and the explainability of what you're finding out. You might be finding out something that is very interesting, but if you change the slide, if you change the bundle of data that you have been mining, the data does not explain the same things. The past has been already past. It will not explain the future. Whenever you're doing some research, the idea is to build an idea, present a model which will be able to explain the future. So that in the future, organizations, individuals, policymakers, they should be able to, make some output, get some takeaway from this. Given this context, the focus of the talk today is to moving away from the what is there in the data, towards the why it is so. If there are findings in the data, why is it so that these findings are important and relevant? And in the process of the journey, introduce greater trust in the findings through methodological rigor, which is often getting lost in this journey. So when we start off the research journey, typically for most researchers, a topic of research has to be timely, relevant, and novel. If I try to do, for example, right now, a lot of research is happening surrounding COVID because all the countries are getting affected by it. That's a very timely topic. But say, for example, the problem is solved in the next 1 year, then somebody else comes and tries to publish a paper on, say, COVID-19 after 3 years, then it would not be timely. We have to talk of a topic which is timely at the time when the submission is being made, so that when we are thinking of a theoretical angle, when we are thinking of a research area, it has to be relevant and timely at the point of publication. So you have to understand that when you're disclosing, when you're exploring a research topic, it will take at least 2 years for it to be completed. At least 2 years to 3 years before it is published. So you have to think of the topic relevance and novelty 3 years hence, not today, but 3 years hence. And you have to also think that such a topic is basically evaluated by the editors from 3 views. To what extent it is going to be generalizable, applicable to multiple other contexts, to what extent the research that you're doing is going to have very high rigor in terms of methodology, and how relevant of that contribution will be when you are publishing it out. So, given this context, a good theoretical model is typically characterized by uniqueness. Nobody else should have done something similar, very similar to that. What you are proposing as a model should be parsimony. It should be very simple to understand. People who can take it away to different contexts and use it, that is generalizability. If it is very complex and they cannot be applicable to another context, then both parsimony and generalizability is adversely impacted. To what extent the research is reproducible, to what extent the research is falsifiable. These are basically the lenses through which objectivity of the research is evaluated, and whether the research has got, internal consistency and can stand the test of time. These are some of the questions that initially, when we are ideating upon a research topic, we need to think of this. Given this, in the data science or even the big data kind of problem, a lot of times there is a challenge or there is a perception whether it's a methodological contribution or a domain contribution. Typically, when we are publishing in management journal, when we are talking about business management as a domain, we are basically publishing in domain contribution. So whenever such data is basically used, big data is basically used, we are trying to find out the interaction of that context or the concept or the domain with the technology artifact and ICT artifact and the stakeholder who are interacting with it. The stakeholder could be government organizations, could be citizens, could be individual users, or could be business organizations. So when this interaction happens, we are basically talking of contributing to the domain. So when we are creating these ISCT artifacts, we are trying to basically extract, analysis from proxy measures that we are getting out of the big data. So when we start this big data driven studies, what we need to do is we have to first start with research questions and what hypothesis we have to develop, because this is an inductive research approach. Many of the researchers start the process by actually looking at the data. That is wrong. People should not look at the data first. People should have the research question and hypothesis developed first so that you can guide through a methodology what is the data that is to be acquired, which is then starting from using the big data analytics blog, visiting the existing literature, you build a theoretical model and do the model validation. Most of the research these days, when you're using the big data analytics block, is happening from stage 2 and stage 3, which is the problem most of the times in this area, because these studies do not contribute back to information systems as a domain. So when we are exploring the studies, the first challenge and the first step comes in how we are collecting the data. Most of the times, because there are so many open platforms where there is a lot of data that is being shared, most of the researchers would try to take a sample data from that database. There are platforms like Elsevier's data, data in brief. There are platforms which share open data in different platforms. You would typically try to take a secondary data and then use a computational method on it. But that is not right. If you're doing that, you're not contributing back to the theory of understanding the hidden linkages within that data. You're basically using a data which has been collected based on a research question which the other researchers had. So your replicability of the research is basically hampered adversely. So whenever you are talking of a research study, the first question is, after you have identified the research question, you have to focus on what is the sampling strategy. How do you identify, the typical samples? The samples would be, in case of a big data research, it could be an individual. An individual in this case could be a person, a user ID in a social media. It could be a mobile application that has been installed in a mobile phone. The sample, the unit of analysis has to be defined. And on the basis of the unit of analysis, whether that is an individual or a context, if I'm exploring a context, say the context is COVID-19, I can pull out all related tweets surrounding COVID-19 and do my study. But I have to define what is my context, what is my unit of analysis. And on the basis of this data collection and sampling strategy, I can move on to my next step, which is basically to bring a theoretical model. So when I'm basically building a theoretical model, I have to ensure that when I'm looking at the data, I have mechanisms to establish reliability and validity in the data. Most of the times, because this area of big data research is very, very new. Most of the people, most of the researchers do not really try to establish reliability and validity, which are very well established in research when it comes to survey-based research, when it comes to research in which you are handing out questionnaires, research in which you are actually asking people to answer to your questions, answer to your maybe interview. When you're asking people to answer to your interview or to your questions, it becomes very easy to establish reliability and validity. But somehow when you are talking of big data research, a lot of times people do not try to address reliability. People do not try to address validity. It is very important to establish that. It helps researchers to move beyond association, to move into causality in terms of the big data. You would be able to explain if findings are rare in the research, what is it that causes those objective findings? The next step is, how do you use big data methods? A lot of times what happens is, when you're talking of big data methods, most of the research papers typically use a lot of descriptive analysis of the data. But then there are lots of advanced algorithms. If I look into text mining, there are lots of algorithms which talk of topic modeling. There are lots of algorithms which talk of word cloud-based representation. But if I'm talking about the individual research methods within text mining, say topic modeling, within topic modeling, there are different approaches like latent Dirichlet allocation. There are approaches like latent semantic analysis. There are approaches like doc to vec. But I have to understand as a researcher, which is the appropriate model based on the nature of the data. A lot of times what happens, because I'm holding these tools, which are computationally available and accessible to me, a lot of times I as a researcher would prefer to use a tool just because it's accessible to me, which is not the right way. We should always understand what is the tool that we are using, what is the method we are using, what are the boundary conditions within which these methods can be used. After we have used these methods, we find out some attributes out of the data. We are able to mine some attributes out of the data. Such attributes could be something from the text, something could be from the networks, could be something from the image. But when we are deriving these attributes, we need to revisit the existing scientific literature so that we can say that, okay, this attribute is a proxy for an existing construct. This attribute is a proxy for some existing concept in the literature. So when we are able to map that to a theory in the literature, then only we can think of how that theory is to be extended. We can then think of how we can, create further additional blocks to the existing model, which will be, which will be kind of incremental building blocks to the existing theory. After we do that, we can develop the research model. And after we develop this research model, what we have to do is, then we can go into the model validation phase, where we have to use a lot of the advanced methods, a lot of the advanced, regression models which are there. It helps us to understand if you're using a method, something like a penalized regression, something like a dimension reduction kind of model, and then subsequently inferential research, then we understand whatever parameters, whatever metrics we are deriving out of big data, it is basically relevant. We can use those dimensions and then come towards inferential analysis. We will be able to move beyond association and go towards causality and event test for reverse causality. And that is what is typically very, very important, because once we move towards causality and reverse causality, then we are basically able to ground back the findings of the existing theory in the research. So if we blow out the big data analytics block, we will see that in the big data analytics block, it is driven by machine learning. If you see my earlier slides, there is a big data analytics block where I'm talking of text mining, network mining, and image mining. In each of these, there are hundreds of methods which are there. So we tried to analyze as an editor all the submissions which are coming in and then going out for trying to do some analysis. So machine learning is the core of this big data analytics research. And we're using different models, different algorithms of machine learning, like deep learning, support vector machine, and many other extreme learning models. So when we are trying to use these models to understand and derive out factors out of the big data, which is purely unstructured data like images, videos, and text. So when we are trying to analyze, say, emails, social media posts, so analyzing the network communication between mobile phones, maybe WhatsApp communication between phones, all these devices which are interacting with each other and individuals interacting with each other, that is creating a lot of unstructured data, and we're using machine learning to do that. And in the space of machine learning, what we are basically deriving are basically parameters which are coming out of pattern association, clustering, classification, network mining, anomaly detection, summarization, and sequence mining. So these are basically the outcome we are deriving out of the machine learning block, which is basically driven by the machine learning algorithms, which are typically called as bio-inspired algorithms. These bio-inspired algorithms allow systems to capture the data, they allow the systems to get the data, the unstructured data, and derive parameters which could be used for establishing relationships. It started very old. It started in the 1960s with 1970s with algorithms like neural networks, genetic algorithms. These days, post 2015, a lot more meta-heuristic algorithms have come up, like artificial plant optimization, flower pollination algorithms. These algorithms help to establish nonlinear relationships in the data. A lot of times what happens if you're using regression-based approaches, you're restricting your findings, you're restricting your analysis to relationships which are considered to be linear or at best piecewise linear. You're not going into non-linearity in the relationships. But when you start moving into machine learning, many of these algorithms allow you to explore non-linearity in the relationships among the constructs of concepts, which are basically extracted out of big data. So if I pick up, say, the first algorithm which is there, say the neural network, there are algorithms within neural network like recurrent neural network, deep learning, then convoluted neural network. Depending on the nature of data, if you're looking at, say, audio or video, maybe something like a recurrent neural network would be good. If you're looking at, say, images, maybe deep learning would be good. But then once you're applying deep learning, once you're applying recurrent neural network, you would be able to extract, some information, some constructs out of that unstructured data. And these constructs have to be mapped with the theoretical models and then validated. Many of the research we as editors typically try to reject is basically because it does not contribute to theory, and a lot of times the exact research article which has been authored is not being kind of represented in the structure that is expected out of big data research. If your article is not having the structural compliance, a lot of times good journals would highly reject it. That's because if you're not following the article structure, definitely in the methods and everything that you're communicating, it is not possible to contribute back to theory in what's in the first stage. Secondly, it would not be possible for somebody else who is reading your article, how that article can be replicated, how that article can contribute back to theory. So you have to ensure that whenever you're documenting the findings, documenting whatever your analysis is highlighting, the article structural compliance is there in the research. So in the big data research, in concluding my discussion, I would say that first focus on how do you establish data acquisition based on the theoretical research questions. How do you establish the validity and reliability of measures? How do you identify which of the computationally derived methods are suitable and can be used in the inferential research model. And this is where a lot of iteration with the existing literature is required. How do you capture data measurement challenges due to biases in the generation of data? How do you ensure that the data is having the minimal trade-off between internal and external validity in the research model? How do you ensure that the data is compatible in measures and you want to minimize the assessment of limitations and trade-offs in the research? These are some of the areas or elements that you have to address in the research whenever you're talking about big data research for theory building in information systems. The data is representative of how individuals, organizations, or society or polity interacts with ICTs, interacts with digital services. Unless you're contributing back to the interaction, the usage and impacts of this technology with the different stakeholders, you're not contributing back to information systems as a discipline. That understanding has to be given very high importance in such research. So with this, these are some of the references which is there in the document. I have not really focused on this. I'd be happy to take any questions and answers you might have based on my talk.
Well, thank you, Dr. Kumar. Before I make some questions, I think there are 3 questions from the audience. Allow me to read one of them each. The first one is from Mr. Arpan RD. Good afternoon, sir. I would like to ask something. I agree with you that big data is a good resource to determine the practice analysis and take some good insights for research. But if we have a limitation to access the big data as resource for our research model, so we get the data from questionnaire. From your point of view, how much differential result between these two about the accuracy or precise level to our research model results? Then is it possible if we have an insight from model from machine learning that using big data, then we validate the result using questionnaire? Thank you.
Thank you. That is absolutely very bang on the target. See, big data research a lot of times cannot capture a lot of research questions. See, as I said, this is the talk on information systems. So when the stakeholders, individuals, organizations, society, or polity interact with a technology artifact, so only then you're actually generating big data. So if your research question is related to the interaction, use, and impacts of technology with individuals, only then you can explore big data. If the technology interface or the technology element is not there, then definitely you cannot use big data. So a lot of pure research areas like, for example, if I'm building theory in psychology or in organization behavior, I might not be able to use big data purely because that big data does not get created. If you're creating that big data, only then you can have a possibility of mining that big data and contributing back to theory. But a lot of times you might not get that big data because that interaction in that context, in that domain does not happen. But if that contradiction, that interaction happens, then it gives you a better chance to use big data as a method to basically analyze and contribute to theory. The reason is this: when you're using big data, there is a chance that you are mining what is called as an honest signal. What is an honest signal? For example, when I'm interacting with an individual, say on WhatsApp or on social media, I'm not really conscious that somebody might be using that data. Since I'm not very conscious that somebody else might be watching and using my data or using my interaction, I tend to have a greater degree of honesty in terms of responding back, as compared to when I'm being given a survey questionnaire. I'm always conscious what I'm filling up in that questionnaire, which typically tend to reflect a lot of biases from the respondents, as well as there are biases in terms of how you're calculating, how you're developing the data, how you are capturing the survey questionnaire, how you are designing the survey instrument. So there is, the first answer is there is no there is no priority, or there is no way to say that one method is different or one method is better than the other, but the methods are different because the research questions have to be different. If you're exploring a research question where an individual is interacting with technology, then there is a possibility you get more of honest signal and it would have lesser degree of biases. So if you're using big data research, the biases or the honest signals are slightly more. But then the problem is there is a huge amount of noise. Having the mechanism using machine learning to distill that noise and coming to the findings which will be usable, which will be more valuable in the way that you can communicate the research and contribute back to theory, that is also a huge challenge in terms of computational, advocating the computational methods, having tools and algorithmically establishing that, as well as at the same time contributing back to the theory. Both the two areas have to be very, very strong when you are doing this big data driven research for top journals.
Okay, thank you. The second question is from Mr. Ridwan Rahmanu from PT Pertamina. It says that almost half of our employee population are millennial generation who are very well aware of state-of-the-art technology. We have also continuously conducted innovation program each year. And with the fact I mentioned earlier, the digitalization topics are predominantly our innovation ideas. However, with certain budget that our company have, and it is not cheap to run a digitalization program, how we effectively redirect our digitalization program to effectively meet our company goals. If you may share, what is the criteria to choose amongst all these digitalization idea to maximize our tangible value creation for the company?
So when you're talking of any digitalization, so let me start with a very basic explanation. There are three concepts. One is digitization, then there is digitalization, and then there is digital transformation. Digitization is when you are just started converting all the data that you have in your organization in physical format to digital format. What you're doing is you would be having journals, ledgers, which are capturing the data. You're converting that to digital format. You're converting that to data into records, which are digital. So when you're doing that, that is basically the movement towards digitization. Now, after the digitization, you need to move to digitalization when you have workflows, enterprise systems in the organizations which can operate on that digital data and then create processes which will create more value. Given how we are moving towards eras like automation, we are moving towards the future of work, what is important is understanding that when we move to digitalization, there will be a lot of workflows which are changing. There'll be a lot of business process re-engineering which are likely to happen when you're moving to the digitalization. The third stage of maturity is basically digital transformation. Digital transformation happens when you are talking of the sum of individual benefits of individual digitalization processes is lesser than the digital transformation of the benefits that you accrue when you are doing the digital transformation of the entire enterprise. So not only functional processes are being digitally transformed, but the entire enterprise is digitally transformed. Now it's not very easy to move towards from the digitization to the digital transformation. You need to have organization readiness, you need to have organization support so that the leaders in the organization, they are able to, kind of push for the individual mid-level managers to have incentive structure, processes and recommendation and recognition systems so that the organization can actually transform to digital transformation. But without that support, there are different theories which talks of how organization and IT alignment happens. And it is the time when drastic IT alignment is required because we are talking of a lot of disruption. And suddenly organizations which were very traditional in their approach of how to use technology, they're now being forced to move towards digital transformation. And that is where a lot of training, a lot of investment, a lot of complementary assets needs to be created by the organization, which will enable employees to move towards this digital transformation.
Okay, the third question is from Mr. Mariono. About big data analysis, it is difficult to convert to valuable insight. There is tricky process to this process. Are you agree to this statement? How to solve this issue? Thank you.
Right, thank you. That's absolutely bang on to my talk. So when we are talking of big data analytics, what happens is converting that individual parameters that you can derive out of big data analytics block depends on a lot of understanding of the methods first and the domain second. So for example, if I'm trying to measure customer sentiment or if I'm trying to measure customer experience, then probably I have to analyze using a method of, say, sentiment mining. But then sentiment mining has got multiple methods within itself. Unless I know the pros and cons, which are the restrictions, what are the method limitation of each method, then I'll not be able to measure the context which I am trying to explore. So for example, if I want to understand the people who are actually talking of, say, Motive, the conference, then I can try to mine the Twitter discussion surrounding Motive. But then if I use a regular sentiment mining algorithm, I might not be able to understand whether people are talking in general about Motive or people are contextually talking about specific, elements of Motive. So then probably I need to do a context featured aspect based polarity mining. Context featured aspect based polarity mining. If I know and do this, only then I can get the actual data and insights. Most of the times what happen, people will use big data analytics block as a black box, and because it is used as a black box, you don't know computationally what's there inside the black box. So it becomes a challenge for us to understand how do we map, how do we identify factors out of big data research. And that is where predominantly major of the challenges happen, because if we are not very sure what's happening inside these black boxes, we would not be able to contribute back to identifying the theoretical models and the factors through which it can be measured.
Okay, thank you. Question number 5 from Mr. Miftahul Zainuddin Irfan from Ubaya. As we know, the Kansai engineering is a method of that used to fulfill the customer satisfaction in terms of emotional aspect, which can be integrated with Kano. So quality function deployment or even robust design to maintain the strategy that should be done by the company. But nowadays, Kansai engineering can use the data mining to determine the Kansai words. According to Professor Arpan, which one creates the nearly best impact on customer satisfaction from the emotional sides? And is it by Kansai data mining to determine Kansai words, but without robust design to propose the development strategy or original Kansai engineering methods? But if it combined with robust design to propose a development strategy? It's a long question.
So actually, that's also a long debate. Uh, there was a time when we used to have manufacturer driven market. So if I talk of the industrial revolutions which happened, initial industrial revolutions focused on manufacturing driven. So I make something, I design something, the buyers would have to take that only, because they did not have too much of options. It was more of a monopolistic market. But then the second industrial evolution changed the focus and moved it towards marketing. You have to understand the customer. You have to understand the customer so that you are creating products not only based on the customer's need, but also you are trying to incorporate slowly the customer's ideas into your design. So when you're talking of this block of big data, or when you're talking, even if I don't move on to big data, but go to basic data mining helps organizations to understand what kind of challenges the customers are facing and what kind of challenges the customers are facing across multiple instances of usage. If I can get that out of maybe the emails that are shared to the organization through platforms like social CRM, social customer relationship management platforms, which will mine your text and give this feedback back to the design engineers, then that is actually the best way, because you are getting the feedback from the customers that across multiple contexts of usage, what are the contexts that require immediate attention, how can you infer what kind of designs, how can you infer what kind of methods can be used so that you can design your product better, you can design your service better. You understand the touch point between the product, the service with the customer, and you understand which require urgent mediation, which requires urgent intervention. So when you do that, you have to combine based on the design thinking of management when you're trying to solve the problems of the customer, along with a data science driven problem statement in which you're using the data to address the design problems.
Well, thank you. I have two last questions, if you can answer very quickly because our time limitation. One is from Mr. Ahmad Bayu Aryawan from Faculty of Animal Husbandry, Halwaleo University, Kendali, Southeast Sulawesi, Indonesia. And from Mr. Moko Priambodo from ITS itself. So the first one is many research journals was checked by mainly for against plagiarism in college or school level. It was simple for citation technology implementation. How journal citations detected by big data? Can big data collect advanced journals? And the second question from Mr. Priambodo related to COVID-19. How to ensure security and safety of the big data facing the uncertain situation such as epidemic case of COVID, so no significant disturbances.
Okay, so let me try to address the first question first. So when you're submitting any manuscript to the journals, first of all, it is very important to submit to journals where the publisher is well known. What happens, many of the big publishers like Elsevier, Taylor Francis, Springer, Wiley, Nature, IEEE, ACM, what happens when you're publishing with this publisher? When you make this submission to the journal first checks whether to what extent your text of the manuscript is already captured in published research across the globe. So if you have higher degree of similarity, say typically beyond 10%, 15%, journal editor would just reject the submission. So a good way before you are submitting to the journal is basically using a platform like Authenticate or Turnitin. Our university uses Turnitin. I, as a associate editor in Elsevier or Springer, I get access to Authenticate, which is given to the individual editors. So using either Authenticate as a subscription or as using Turnitin as a subscription, it is very important to ensure that your manuscript that you are submitting is less than 10% or 15% max. Now, how does this platform basically give you this similarity? This is where they are using also big data analytics, or rather text mining, to basically identify how you are exploiting the resources which are available to you. Are you using them ethically or not? You are expected to build your theory, build everything based on theoretical blocks and literature which is already published, but you should do that in the ethical manner. So if you're using this Turnitin software, this software basically give you input surrounding to what extent the students that you are working with you, they have brought out kind of original thinking in the manuscript. They have brought out an original thinking in the project that you are submitting to a journal. A lot of times, if you're not going with a reputed journal, they might not use these kind of checks and balances. And after publication, there are two things that happen. If you are publishing in journals which are not very reputed, slowly it starts building up your gray profile, and then you might not be able to publish in good journals. And the other thing is that if you are publishing in these journals, a lot of times these journals are, what we call as predatory journals. So if you're publishing in predatory journals, then that becomes a very serious drawback on the career. So you have to ensure that you don't publish in predatory journals. I think the second question which was there was related to COVID. So what's happening in COVID, there are lots of special issues which are coming in from management, which are coming in from disaster management kind of perspective. In big data research, what's happening is it is possible to understand using different approaches, like, for example, network mining, then text mining, understanding which are the hotspots in the different countries which are getting affected by COVID. What are the hotspots spreading like? If you are able to find out these are the, the centrality in terms of these are the places where the maximum concentration of COVID infection happen, then it is possible to use big data analytics and say that, okay, you don't need to lock down the entire country. You can lock down the specific locations, or you can lock down the travel between the specific location. There is one initiative that has been provided by Facebook. Facebook is allowing free access to its data, that is its travel data. If you get access to Facebook travel data, what happens is you understand whenever a person has got a mobile phone and that person is using Facebook as an application in the mobile phone, whenever the person is moving from one location, one area to another area, so that movement is getting captured in the Facebook, server. So then that allows data scientists to basically mine and understand what are the impact of lockdowns, what is the impact of movement. Does movement actually cause problems like, greater degree of proliferation of COVID infections? So that kind of big data problems or grand problems can be, checked out. Then big data, a lot of problems surrounding images. You have a lot of satellites taking regular images from very high up positions across the world, across surrounding the Earth. Is it possible to create heat maps surrounding where COVID infections are happening and on a real-time basis predict how one particular location is going to be more critical over time, say over the next 30 days? These kind of predictions can be done using, image mining, big data analytics blocks. I hope I have been able to answer very shortly the two questions that were asked.
Thank you, Dr. Carr. As a closing part, I have one very short question. We know that big data analytics technology and management is one of the most important aspect in Industrial Revolution 4.0. But how we can translate and we prepare this in different industries, because I think each industry has its own characteristics and readiness to face the Industrial Revolution 4.0. So can you give some elaboration a little bit on the pragmatic or application side on this?
Right. So in fact, that is coming out hugely. So if you look at this block in my page only, the first block is called data acquisition. In the data acquisition, you see that the second point which is mentioned is sensor devices and networks. So sensors devices could be something like Internet of Things, could be something like actuators, could be something like sensors which are coming out at different stages that you're implementing them in the big data analytics. So they will be in the industry 4.0 creating the data. Now, when you're using, technologies like fog computing, or you're using other technologies to collect that data in some platform, maybe in the cloud, then you can run your big data analytics on the cloud to make meaning out of these data that you're capturing out of sensors. So what kind of meaning or what kind of analysis can be done using these big data analytics? I'll try to give a couple of examples. One of the examples typically that's happening is very frequently, a lot of benefits have been realized globally, is basically explaining predictive maintenance. Earlier, predictive maintenance was typically done that you would know that every month this machine is supposed to go for maintenance. Now, what is required is you don't need to do a preemptive maintenance. Whenever the actual degradation happens in the machine, there will be sensors which will give that information back to the system that this is the time when the predictive maintenance is required. You are effectively saving a lot of cost that you would be doing the maintenance every 6 months. Now, probably after you install these devices and you're doing the predictive maintenance based on big data analytics, you're probably doing it once in 7 months, once in 10 months. And that is basically creating a lot of benefit for the organization. I'll give another example. A lot of big data analytics are basically used for logistics. If you look at shipyards, if you're looking at logistics, forward logistics or reverse logistics, in these platforms, many of the times the containers would be having these sensors. So what's happening in these sensors, they will be providing information surrounding, say, the humidity within the containers. So if you are, say, transferring, say, vegetables and the humidity drops beyond a certain level, or you are transferring something like dry grains, the humidity within the vehicle at specific locations, not the entire vehicle, but at specific location, due to spillage or some other problem during the transmit, there is a signal from the sensors that this is happening. Then you need to have immediate addressal of that logistics. You need to have immediate mechanisms of intervention to ensure that the logistics does not spoil the material in transit. And that is where a lot of applications of big data is happening, surrounding supply chain management, surrounding logistics management, lot more applications happening in that space.
Thank you, Dr. Kumar. Thank you for your presentation and our productive discussion today. And we really hope that we can continue our cooperation in the future. So thank you and congratulations.
Thank you so much. Thank you so much for your kind invitation today. It has been really great to interact and have these questions. Very, very insightful.
And as an appreciation on behalf of the organizing committee, I would like you to receive this certificate of appreciation from us, Dr. Arpan Kumar. Thank you very much.
Thank you so much. Thank you so much. Grateful to this.
Thank you.
Thank you, thank you.
Thank you. Thank you, Dr. Carl, for your very nice speech.
Thank you so much. Thank you. It has been really great to have this talk. Thank you so much for the invitation.
Terima kasih, silakan panitia.
Thank you for our moderator in this session. Now we would like to inform that all of the participants may join the second parallel session on the room for each papers based on the instruction given. Thank you for your attention.
Terima kasih Pak Tatang.
Sama, Pak.
Terima kasih Pak Tatang.
Sama-sama.
so ending to you. We'll shine again to you. Suddenly love so